Good afternoon, colleagues. I'm sorry to be presenting this paper via video instead of in person today. I know I'm missing a very exciting conference. My paper is titled The Global Student Achievement Gap in Math and Science, Insights from Asia. It starts with the observation that students in Singapore, Japan, and China have the highest achievement test scores in the world in mathematics and science. These countries have consistently been the top 3 to 5 in the world over the last 15 years of comparisons of math and science achievement. By contrast, the US has ranked below their Asian counterparts. They have ranked number 8 through 13th through the years. What accounts for this global achievement gap between Asian students and the American students? Do teaching methods in math and science differ in Asia? Are teachers or students' attitudes there so different from Americans? Are there national policies or cultural patterns that explain the achievement gap? Over the last several years, I've been observing mathematics and science classrooms in Singapore, Japan, China, and the USA. I've done interviews and focus groups discussions with teachers from these classrooms. I've had roundtable discussions on these topics with my colleagues on this panel. We brought to bear our diverse experiences, observations, and expertise on this topic. This paper then is a summary and synthesis of these observations, focus groups, discussions, and Socratic dialogue. Several factors we expected to explain the achievement gap were empirically or logically eliminated in this analysis. First of all, class size. In the US, it is assumed that large class size decreases effective teaching and learning, but Asian classrooms are generally large. In China, a typical 5th grade math class has 45 students. In interviews and focus groups, Asian teachers did not see large class size as an impediment to learning and achievement. Next, US educators view instructional technology as necessary to motivate students for learning. They also see technologies as indispensable tools for learning. Computers and calculators are common in US math classes. By contrast, there are no calculators or computers in the primary and middle school math classrooms in Singapore, China, and Japan. In Japan, for example, we observed students in a geometry class using protractors, rulers, and right triangles with colored pencils for working problems. The teacher used larger versions of these tools with colored chalk on traditional chalkboards. 8th grade science classes were held in traditional classrooms in Singapore, China, and in the USA. In Japan, an 8th grade biology class was taught in a chemistry lab. The relative absence of computers in Asian math and science classrooms shatters the belief that technologies are necessary for high achievement. What about teaching methods in Asia and the USA? Teaching methods were mostly didactic in the middle grades in all 4 countries. The most common methods were lecture presentation, recitation, and discussion. However, at the elementary grades in the USA, Japan, and Singapore, hands-on inquiry methods were also common. Lecture and workbook exercises were used in the 4th grade science classes in China. In Asia, a Singapore 4th grade science class was the only one where a computer was used in the lesson. The teacher guided the students to use a Google search to look up definitions on density and formulas for converting measurements. The variety and mix of teaching methods used in classrooms across all nations imply there is no particular teaching method in Asia responsible for their higher achievement test scores. Similarly, teacher characteristics could not be associated with the global achievement gap. The wide range of years of experience among the teachers is the case in all nations. In all countries, there are examples of dynamic, passionate, and exemplary teachers. There are also mediocre, less dynamic teachers, some of whom were stressed, demoralized, or burned out. We conclude that these teacher characteristics do not explain the achievement gap in math and science. Patterns across Asia that differ from that of the USA included, first, student demeanor, second, cultural and family expectations about preparing for tests, and third, the professional status and esteem of teachers. In our observations, there was a noticeable contrast in student demeanor between US students and the Asian students. In general, the Asian students were more serious and focused on the academic tasks than their US counterparts. School bells governed the start and end of classes in all Asian schools, including the primary grades. While there was much socializing and chatter before the bell, this stopped when the bell rang in the Asian schools. The students stood to greet the teacher and then attended to the instructions and tasks immediately. There was more variation in student attentiveness and task focus among the US students in all grades. Teachers and parents in all 4 nations have expectations for student performance on standardized tests in principle and in rhetoric. But Asian educators pointed to cram schools and family expectations which strongly reinforce student motivation and performance on those exams. In contrast, US families and schools generally do not support students with extra tutorials, classes, or cram schools to help the students prepare for the tests. US educators also oppose teaching to the test and are critical of the validity and uses of standardized achievement tests. Compared to the unambiguous support Asian students receive, there is a climate of controversy in the US about achievement tests. This controversy may be communicating an ambiguous message to students and parents. The critical view of achievement tests could be contributing to US students being less motivated and preparing less than their Asian counterparts for the tests. The respect and professional regard and esteem for teachers in China, Japan, and Singapore have been traditionally high in comparison to that of the USA. The typical class contact hours for government school teachers in China is 3 hours per day, with other hours devoted to professional development. The higher esteem for teachers and value placed on education among Chinese, Japanese, and Singaporeans may be an important contrast to those variables in the US. It is possible that the high professional regard and esteem given to Asian teachers is a variable that can account for the international achievement gap. In conclusion, the analysis of our observations, interviews, and focus group discussions has revealed 3 potential variables to account for the international achievement gap in math and science. First, the consistently serious student demeanor in Asia. Second, the high expectations and real support for students to score high on standardized achievement tests. And 3, the high professional regard given teachers in Asia. Of course, empirical studies are needed to confirm these conclusions, but the identification of these variables can already help US educators to reflect on how our policies, practices, and expectations may be contributing to the global achievement gap in math and science.